Hello friends, in the last few videos we have been discussing about measurement of physical quantities and then errors in measurement arising due to various factors like some systematic errors or then random errors or instrumental errors and so on. Okay, now we even discussed about the combinations of errors like if I have my physical quantity z is equal to a plus b, then delta z would be equal to delta A plus delta B, and then if it is minus, then this would be again minus. That is what we would think, but then there is no minus sign here because the error is going to be maximum when both are positive or both are negative. It can be on either side, it can be on plus side or it can be on minus side, correct? So whether it is plus or minus here, you are going to get positive sum of the errors. And also we had z is equal to a upon b. Here delta z upon z is equal to delta a upon a plus delta b upon b. Z is equal to a into b. Again we have delta z upon z is equal to delta a upon a plus delta b upon b, and this is what we have derived, we have proved this, correct? Only that here it is the absolute error, in sum and difference it is the absolute error, whereas here it is the fractional error or relative error, the error divided by the physical value of the physical quantity there. Okay, now in this video we are going to do some numerical problems. Okay, to start with, I'll take example of calculating equivalent resistance. I have two resistors, R1 is equal to and R2 is equal to. Now R1 is 8 plus or minus 0.5 ohm, and my R2 is measured maybe with some different instrument. It would be, let us say, 12 plus or minus 0.8 ohm. Okay, now what is the, now these resistors, they are connected in series. Okay, so when you connect two resistors in series, what is the resultant? Okay, what is the equivalent resistance? Is it not a sum of two? Correct. So my equivalent series resistance would be equal to R1 plus R2. So as we have our formula, Z is equal to A plus B, then delta Z would be equal to A plus delta Z would be equal to delta A plus delta B. So here I can say delta RS is equal to delta R1 plus delta R2. Right. Now, so my delta R1 is 0.5 plus 0.8. So that would be equal to how much? It would be 1.3 ohm. Correct. We want to find the error in calculating the series resistance, and that would be 1.3 ohm. Now if we are asked to find the percent or maybe fractional error or relative error, then what we need to do is it would be delta RS upon RS. Okay, now what is my RS? My RS is equal to 8 plus 12, so that would be equal to 20, correct? So over here I am going to write 20. What was my delta RS? So delta RS is equal to 1.3 upon 12 plus 8 is 20. So that would be how much? It would be 0.65, right? It would be 0.65. Now here it is expressed as a fraction. Okay, it is a ratio of resistance with resistance, so it won't have any unit, correct? So then I can say that RS would be equal to, it would be 20 plus or minus, it would be 1.3 ohm. Actually I should write it as 20 ohm plus or minus 1.3 ohm, or I would write as 20 ohm plus or minus 0.65%. So that is how we calculate the percentage error in measuring the series resistance. Correct. So that is one part. What if I connect these two resistors in parallel? Okay, let us see what to do over there. I'm going to erase this. I have the same resistors. Okay. Now what is the formula for equivalent resistance when they are connected in parallel? So it would be 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Right? So my Rp is going to be equal to R1 R2 upon R1 plus R2. I have taken LCM, cross multiplied, and then I have taken the reciprocal of that. I am writing this directly. Correct. So this is going to be equal to 8 and 12, right? So it is 8 into 12 upon 8 plus 12. So that would be equal to, right? So how much would that be? It would be equal to correct. So it would be 4.8 ohm. Okay, this is my Rp. Now I need to find the fractional error in this. Okay, so how do I do that? So for that, I'm going to use differentiation. You may have seen the other videos on calculus in physics. Over there, whatever calculus is needed, derivatives and differentiation for physics, it is explained over there. You can refer to that, but then for now I'm going to directly differentiate this. So 1 upon Rp, it is going to be delta Rp upon Rp square is equal to, over here it is going to be delta R1 upon R1 square plus delta R2 upon R2 square. Now what is delta R1 and delta R2? Delta R1 and delta R2 are the absolute errors in R1 and R2, and we want to find the absolute error in the parallel resistance. So obviously if I want to calculate delta Rp, I have to take this Rp square on that side. Correct. So therefore I am going to write here delta Rp is equal to Rp square upon R1 square delta R1 plus Rp square upon R2 square delta R2. Correct. So now what is my Rp? My Rp is, maybe I can write it as it is, or then I can do 48 upon 10, and 48 upon 10 would be equal to 48 upon 10, right? I have written 4.8 here, so maybe I'll just put 5 here and 24 here, so 24 upon 5. Correct. So 24 upon 5 into, what is my R1? R1 is 8, and then whole square here into delta R1. Delta R1 is 0.5 plus, I am leaving some space here. Okay. Now what is my Rp? Rp is again 24 upon 5 into, this is 12 whole square into 0.8 here. Now why did I leave this space here? what I'm going to do is I'm going to have delta rp. I want to express it as percentage. So if I want to express as percentage, then I'll multiply that by 100. So now here I can do this, 3 here and 2 here. So it is 9 upon 25 into 0.5 plus it would be 4 upon 25 into 0.8, correct? So whatever value that you get here, that would be equal to the error in delta rp, correct? And then when you divide this delta rp by your rp, that is 4.8, okay, if you do that, then you get the fractional error in the parallel resistance. So that is how we are going to use it. In the next video we are going to do one more problem of this type. Maybe it would be little simpler than this, but then it would give you fair idea about how we deal with errors and uncertainties. Thank you so much.